In this video, we will be seeing how to find pairs of songs which are divisible by 60 and build a solution in JavaScript while also computing the time complexity and space complexity of the solution. In terms of input, we will be given an array called as time, and at the ith index, the value is going to be the representation of number of seconds the track has. So what we mean to say is at index of 1, the song has 30 seconds with an ID of 1. At index of 2, the song has 150 seconds in terms of duration at ID of 2. And we have to find pairs which will be divisible by 60. What we mean by pair is we have to find two values A and B whose sum is going to be divisible by 60 from the input that we have received. And to make sure that we can say that this pair is divisible by 60, we have to do a modulo operation with 60, and if that modulo operation is giving you 0, that means it is divisible. And the index of A that we have has to be less than the index of B that we have. And in the return, we have to return the count of all pairs that can be formed which are divisible by 60. And with this expression that we have formed here from the problem statement, this being addition associated with a modulo operation, what we can say is that the representation can be written as A mod of 60 plus B mod of 60. The whole mod of 60 is equal to 0. This operation is called as a distributive property of the modulo function whenever addition is involved. And this representation then further be adapted to say that if A mod of 60 is 0 and B mod of 60 is also 0. What that means is, given two inputs, the first input is divisible by 60 and the second input is also divisible by 60, then we say that the sum of both these inputs would also be divisible by 60. So this is our first criteria to check whether the pair is divisible by 60 or not. So this is criteria 1. Criteria 2 is that when A mod 60 is not equal to 0, in that case, if we are able to find B, that the remainder of B and the remainder of A then add up to 60, then we can say this pair is divisible by 60. What that means is A mod of 60 plus B mod of 60. If this value is 60, we can safely say that the pair will be divisible by 60. So this is the second criteria that we will be using to check. So we have created two criteria based on which we will try to see whether the pair can be formed or not. And with this in mind, we will proceed ahead to try to reach a solution. So given the input that we have with us, in this case, this is the input that array that we have received. Let's try to use these two condition checks throughout the input that we have received and reach a solution. What we will be doing is using a map data structure, and that map is going to keep a track of remainders that you are going to find in the process. So map of remainders that we have with us, and this map is going to store the values that we find throughout the iteration that we are going to cover. And along with this, we will keep track of a count value, which is going to be a pair count, which we will return in the end, which gets initialized with 0. And let's now start with the first element in the array that we have received. The first element is 60. What I will do is do a modulo operation. So I will say 60 mod of 60. I will do a Euclidean division here. 6 ones are 6. I'm left with 0. So I will say that my first criteria is now satisfied, wherein A has to be divisible by 60. But there is another catch here, that along with A, B also has to be divisible by 60. So I have not yet found a B because I'm just at the first element so far. And if I find a 0 remainder here, which is the remainder that is the value of the modulo operation, I will say against 0 keep a track of the value that I have found. And if you had already found this value, in our case it was empty, so let's assume that the empty value is 0. We didn't have any remainder that we could say forms a pair with our A. So A and B, the B was missing and nothing is so far, so we couldn't say that a pair has been found. So I will just now say initialize this to 1 for a remainder of 0, because this is in turn a map of remainders. Then I will just move on to the next element in the array that I have. I will say 30 here, I will say 60 again. 30 being less than our 60, it cannot be divided, so I will just do 0 on the top in terms of quotient, and I will put 0 here. I am left with 30. This is my another remainder that I have. Let's put a triangle around this. Now what I will do is, because this is a non-zero remainder, we will try to check the second condition now. The second condition says that try to find B remainder that is going to be the complement. Adding up both the values, you try to get 60. If that is possible, then you have found a pair. So I will go back to my condition that I have written, which says A mod 60 plus B mod 60 is 60. And to find a complement, I can represent it in simpler words as B mod 60, that is the remainder of B, is going to be 60 minus A mod 60, which can then be represented with our current implementation as 60 minus 30 that we have with us. And with this in mind, let's proceed ahead, wherein we say now this 30 value that we have received, we will try to check if this complement exists in a map. I will check 30 here. I don't see any 30 in the map that we currently have. So if you see the value, then you could have said that you have found a pair, but because you don't see the value, we have not found a pair. And then what we will do is this 30, that is A mod of 60, we will just put it in a map. So I will say here 30 and put a track of 1, and our count still stays at 0. Then I will move on to the next element, which is 150. So I will say mod 6 2s are 120. I'm left with 30. This is my remainder that I have received. With this remainder that I have, it is also non-zero, so the first condition doesn't get satisfied. Move on to the second condition. I will try to do 60 minus 30. I am left with 30. Now I will check, does this 30 exist in my map or not? I can see that 30 exists in my map. That means I have found my pair. So these two elements that I have here will form a pair at this point. And that's the first pair that we are looking for. And then I increment my pair counter, because just to verify, if I say 30 plus 150, that is going to give me 180. 180 is divisible by 60. So if you just divide by 60, you will say 6 3s are 180, and this is 0. So you have found the value that is divisible after you form a pair from it, and the counter becomes 1 from 0. And then the next step is to increment the counter associated with this remainder of A that we found, and that counter is currently 1, and the counter will now change to 2. Then we move ahead in the operation to the next element that we have. The next element that we have is 100. So I will just do 60 100 here. 6 1s are 60. I am left with 40. This is my remainder of A. Let's put a box around it. I will try to see if it's satisfying the first condition. No, it isn't, because it's a non-zero remainder. I will do 60 minus 40. I am left with 20. I will check if 20 exists in my map of remainders or not, to make sure that the complement is achieved, which is not the case here. So if that is not the case, I will just put this remainder of A in my map again. Against it, I will trigger a counter of 1 and I will move forward. Then the next element is 40. I will say for this 40, again do mod 40 being less than 60. I will just put a 0 here. This becomes 0. I'm left with 40 as my remainder of A again. And now what I will do is again do 60 minus 40, which is going to give me 20. Now I will see, hey, does this 20 exists in my map or not? I don't see that 20 exists in my map because the complement cannot be formed. I can only see 0, 30 and 40. So if it doesn't exist, I just increment the counter against the remainder of A which exists. So from 1, now it will become 2 and I just proceed ahead. Then the next element is 80. Now for this element, again I do the mod, and now what will happen is I will put this value as a remainder of A, which is 20. I will do 60 minus 20, which is going to give me 40. I will now check if this 40 that I have here exists in my map or not. 40 exists in my map with a counter of 2. So I found 2 instances of this 40 as a remainder. One was here and another was here. So I can now safely say that this will form a pair with both those. So one pair will be this, and another pair will be this and this. And this counter will just get added. So I will now say 80 and 100 form one pair and 80 and 40 form another pair. And now I will increment the counter with plus 2. So 1 plus 2 will become 3. And just move ahead. And before moving ahead, I will just see this remainder and add the counter in my map. And the last value in the map is 120. I will see 60, 6 2s are 120. I'm left with a remainder of 0. And initially we said for this 60, we had got a remainder of 0 and we had put a value in the map. And now we will just check if a value exists in the map or not. We have a value in the map here against this value of ours. So we will just add that value to our counter now. And the pair that gets formed from this is going to be 60 and 120, which gives a value that is divisible by 60. And now the pair count will increase to 4. And to end the iteration, the value of here against 0 will increase to 2. And that's the end of the loop that we were running. And we are left with 4 pair count, which is our output. And we saw the pairs that could be formed here using this map data structure of remainders. And that's pretty much it in terms of implementation. Now let's jump into the coding aspect of it. So what we said here is that we will be using a data structure map, and I can just represent it as let remainder map is equal to a new map that I will be having. I'm also going to have a pair count that is going to be initialized to 0, and in the end I'm just going to return this pair count that I have, because that's the goal of this whole solution that we are trying to build here. And then we said we will go from start till the length of our input that we have received. So I will just say for let a of the time input that we have received, we will try to first find the remainder of a. So I will say remainder of a is going to be a mod of 60. And then I will check this remainder with the value that I have received is 0 or not for my first condition. So first condition says that a has to be divisible by 60, and you also need a b that will be divisible by 60. So I will say if the remainder of a is having a value of 0, that means it is divisible, then you do the condition 1 check. Otherwise you will do the condition 2 check of yours. And the condition 1 check says that if you already have a, try to find the value against the remainder of 0, because against 0 we are trying to see if we can form a pair, and that pair will be something like pair count is going to be plus or equals to this remainder map of ours that we have, along with the complement that we are looking for. So I will just say against the remainder map of 0 that we have, whatever value you have, just add it up. So you get the value and add it up, or you just default to 0 in the first initialization case that you have. Otherwise, with your count, the value will just get added up. Now, going back to the second condition that we have, wherein we said if you are not able to find a 0 value for your remainder, then try to find a complement b. So I will say remainder of b is going to be the complement that we are looking for, which is going to be basically 60 minus the remainder of a that we have already found with us, which we are going to try to see if it forms a pair now. And to do that, what we will do is just take the value that we have against the map that we are looking for, and then check if this remainder that we have received is going to be forming existing in the map or not. And if it exists in the map, pick up that value and increment the count. Otherwise, just add 0 to that count to increment it further. What that means is I will just take the map, I will try to get the value that I have in the map for this remainder of b, which is basically complement of my remainder of a, and then I will try to increment my pair count based on that value which exists. So either I find my complement in my map, or if I don't find the complement in the map, I will just say 0 associated with it, because then if I don't find it, it's defaulting to 0. And that's pretty much it in terms of implementation. The first check is a condition 1 that we said, wherein once you find a that has a remainder of 0, you try to just find b also that will be having a remainder of 0. So you just try to find the remainder, which is by default going to be 0. If it exists, whatever count it has, just take it up and increment your pair counter. Otherwise, default to 0. And then your condition 2 that you have, which is going to say that if you find remainder that is a non-zero value, then try to find b that is going to complement your a. And this is the representation that says 60 minus the remainder of a is going to give you a remainder of b. And then you just try to find that remainder of b value which you have in the map. If you don't have it in the map, then you just default to 0. And then the last aspect here is going to be incrementing the counter for the remainder of a that you get in your map. And that is going to do something like remainder map dot set the remainder of a with some value, and that some value is going to be the existing value of remainder of a that you have. So I will just say get the remainder of a initially, or use 0, and then to this value that we have received, I will just increment it, and that increment will just say +1. So this is the increment aspect of it, wherein I will just pick up the value and then I will increment it by 1. And that's pretty much it in terms of the logic aspect. So you will keep the tracker, you will use a map of trying to put the track of remainders, you will go through these 2 condition checks, and at the end I'm just going to say for that remainder of a that you have received, just keep track of the counter that you have, get the existing count and just increment it by 1. And that's pretty much it in terms of implementation. And in terms of the time complexity that is going to be involved here, that is going to be big O of n, because we said go from the first element to the last element in this loop, and then perform these checks and update the set. And in terms of the set operations here, this is going to be big O of 1, this is also going to be big O of 1 in terms of constant lookup times. This is also 1, this is also 1. So big of n plus big of 1, 1, 2, 3, 4 times is going to be big of n itself. And in terms of the space complexity that is going to involve here is going to be big O of 1, because this remainder map that we are going to maintain is going to be only going from 0 until 59. It's never going to cross the value of 60, because that's where we are doing the divisibility check. And because of that, the space will always be constant in the map. That is, at max it can have up to 59 from 0, and that's why the space complexity is going to be big of 1. And that's pretty much it. Thank you for watching. Please like and subscribe.